Okay, there we go.
Okay. All right. Thanks for joining, guys. So this is the talk about dream2nix, which is a framework we started working on during the summer of Nix a few weeks ago. And it's a generic framework for language to Nix tools. And the general motivation behind this is to bring a bit more automation and scalability to package management with Nix. All right. So quickly, the outline of my talk. First, I'm going to explain a little bit what to-nix tools are and why we need them. Then I want to talk about the problems of the current approaches of the current to-nix tools. Then I want to start with a quick demonstration about the current dream2nix tool to give you an idea like what it does and how it works. And then I will explain what are the core concepts behind it. I will talk a little bit about the architecture. And then I will explain a bit what kind of benefits I see if we get this, if we can adopt this in Nix packages. And then we hopefully have some time for some questions or discussions. Okay, so before I start, I just want to clarify, not to confuse you, a few times during this talk, I'm going to talk about recursive Nix. And what I mean by this is whenever a Nix evaluation depends on a build output. So whenever Nix has to build something first in order to figure out what to build. And there's different ways of doing it. One of them is called import from derivation. One of them is recursive Nix, which is an experimental feature. And the third one is RFC92 computed derivations, which is like still in early work in progress. But whenever I talk about recursive Nix, I mean any of these three, because basically it's kind of just different implementations for a similar style of using Nix. All right, so what are to-nix tools? To-nix tools are there to translate packages from other build systems to Nix. In other terms, it's basically an automated way of creating Nix expressions or Nix derivations. Why do we use it? It saves us a lot of time. And in some cases, the complexity is just too big to be manageable by hand. Another reason why a user might choose to use these tools is because of knowledge. I guess some Nix beginners, for them, it's difficult to write Nix expressions. They don't yet understand all the necessary parts which are required. And so it's easier for them to use such a tool. Yeah. Oh, maybe I should turn on my camera. All right. Here we go. Hello. All right. So what are the basic steps that need to happen when converting something to Nix? There's in general four basic steps. The first one is we have to parse some metadata. Usually this metadata comes from the upstream source repository or Git repository, but it can also just be individual files which describe a package. So what is metadata? Just to give a few examples, metadata of a package would be the version or the name of the package, its dependencies, and maybe some build instructions. This is what I consider metadata here. The second step is resolving dependencies. And this can be either quite simple or very difficult. It totally depends on the metadata. So if the metadata is, for example, a log file, then it already gives us resolved dependencies and we know exactly which URLs we need to fetch. Then we don't really have to do this step, or this step is going to be very easy. But sometimes the metadata does not exactly specify what is required, and we have to, for example, query like an online package index or something like this to find out which packages are actually needed to build this package. So this is step number 2. And when we have finished that and we actually know what are our dependencies and what are our resources that we need for the build. We need to fetch them, and the last step will be building it. So those are the 4 phases, which are basically shared across all 2nix tools. They're all done a little bit different, and this is like where we have our first problem. They're often not very separated, and they're kind of done in one step, kind of. So we have a maintenance problem across the existing 2nix tools. Also, usually there is only like one person or two persons who understand the code base of a 2nix tool and who can maintain it. Upstream tool chain often moves on, and if the maintainers don't maintain the thing regularly, the 2nix tool, then it gets quickly outdated. And yeah, also since they don't really follow like a common structure, and they all do it a little bit different, it's hard to debug. They're often very monolithic, so when there's like a problem, it's hard to debug it. Yeah. So another big problem is usability. Since there's so many different tools and they're all done slightly different, we have different user interfaces. They all provide different features, and they're only compatible to different metadata formats. So, for example, within one ecosystem like Node.js, there exists different log file formats, and often, if I have another log file format, I need to switch the tool, and this really shouldn't be necessary. This makes it like, this makes it unnecessarily complex. Customizability is also an important topic, which is not always done right. Some tools have good customization options, some tools have not. But if they do, then it's different from tool to tool. And again, you really have to learn a specific tool in order to understand how to use it and how to customize it. Often you have to go and read the source code of the tool to see like what you need to change in order to modify the build process. So yeah, they don't really share like a common standard for customization interfaces. What many of those tools do is generate Nix code, and there can be good reasons to generate Nix code. But the general problem with this is that we end up having a lot of duplicated code. So we're kind of polluting repositories like nixpkgs. And since we have the logic in many different places, if we want to update the logic or fix some bug or something like this, we have to fix it in many places, or we have to regenerate all the packages. So it makes it a little bit harder to maintain. It also makes it hard to audit, because if somebody makes a pull request with 10,000 lines of Nix code, it's very unlikely that any person's going to read all the lines. Like, yeah, it's not optimal for auditing. Another thing which we're encountering are fragile fetches or large fixed output derivation fetches. So this is when people put complex logic inside a fixed output derivation, which is originally meant to do something very simple. An example for this would be build Rust trade or build Go modules. They execute upstream tool chain in this fixed output derivation, which often does other tasks like dependency resolution or vendoring, which is kind of like a transformation executed on the downloaded data. So if any of this logic is changed in the upstream tool chain, the hash will break, and we have many different places where we need to fix hashes. So this is something that we do not want to do in dream2nix. Another thing that I've seen sometimes is combined installing. So what do I mean by this? Usually the idea of Nix is that for every dependency, we have an individual derivation and individual packages, an individual package that gives some benefits for caching, for example. If two packages share 99% of the dependencies, then I don't have to download all those dependencies twice and only once. I can cache them nicely. The build times will be faster. The build in general is more incremental. If I have a little change in the master package, I only have to rebuild that package and not all the packages again. But the way it's done with some nix tools right now is that they install like 1,000 packages in one derivation, which is very bad for caching, very bad for build times. So this is something we try to avoid. Another thing that can be painful is updating packages. The problem is that the workflows here differ between different build systems. And just because I know how to update packages in one build system doesn't necessarily mean I will do a good job in updating package in another build system. Sometimes we have automatic update scripts. That's good. But often they just don't exist. And even if they exist, again, we have the problem that it's highly duplicated logic. They're all kind of doing the same thing, but just a little bit different. And it's unnecessarily complex. And also the scripts need to be maintained. Another point is, I think the way the tools are done right now, it makes it hard to innovate because we have these many separated tools where individual maintainers maintain this tool, and maybe someone has a good idea and has some breakthrough, but it's not going to be adopted ecosystem-wide because the tools don't really share a common code base, which would make it easy to adopt changes for all tools. So the idea of dream2nix is to provide this common base where we can experiment with new Nix features, with new approaches, and if something works well, we can adopt it for all tools. Another topic is sharing dependencies. This is a difficult topic with no definite answer, I would say. So what is sharing dependencies? Sharing dependencies usually mean if we build a package, do we want to let each package manage the dependencies individually, or do we try to maintain like some common set of core dependencies that other packages depend on? Now there's advantages and disadvantages of both models. Just to name them quickly, the advantages of sharing dependencies is we have less packages to maintain in total. There will be less generated code, or less code in general. It doesn't matter if it's generated or not. We have caching advantages, obviously, and the size of Nix packages will be smaller. The disadvantages of sharing dependencies is that obviously whenever you update something, it has much more side effects. So updating one package might break another package, and then you have to touch the package as well and break other packages and things like this. So if everything is managed together, it's harder to scale, it's harder to maintain, and it's much more likely to get merge conflicts. So one of the examples for that would be this common global node packages set we have in Nix packages. Whenever somebody tries to update it, I think there's a lot of merge conflicts usually. Okay, so the last point, the last problem I want to talk about is creating new Nix solutions. I think there's still many programming languages and frameworks where we want to have Nix solutions and we don't have them yet. So there's still many more Nix solutions to be built. But right now the problem is it takes some time to get into the topic. It takes some time for people to figure out what it takes to build them. And it's often, you can look at other Nix tools, but since the parts which are reusable are not properly separated from the parts which are not, it's hard to figure out. Stuff would have to be refactored, and often it's just easier to just rewrite the whole thing from scratch. So this is something we want to prevent with dream2nix. We want to build like a common base where everybody can attach modules and build on top of, and people don't need to fix the same problems again and again and again. All right, that was the intro, and now I have some little demonstration. Need to share my whole screen, I guess. All right, here we go. Can you see my screen?
Looks good.
All right. Okay. So this is a empty directory. This is my new repository. But you can also just imagine that this is nixpkgs. I'll just do the thing in a clean repository to make it more clear, like what files are added. So I will show two approaches now on how to use dream2nix. The first one will be without any recursive nix or import from derivation. So that's the approach. If we want to use it in nixpkgs, we would have to use it that way. And the second approach I'm going to show is how to use it through import from derivation. Okay. So in order to get an entry point, let's create an all packages.nix file. Make this a little bit bigger. Okay. So let's say we import packages. And we have our set of packages. The first thing we need to do in order to use dream2nix is install dream2nix into that repository. And this is done like this. We do a nix run username dream2nix, and we want to execute the install app, and we want to install in the dream2nix subdirectory. Oh, by the way, if you want to reproduce this and try this, I will have all those commands in some slides, and I can send that to you as a PDF, so you don't need to type it now. But obviously, if you want, you can. All right. So now dream2nix is installed. We have this dream2nix subdirectory with a lot of files. So this is the framework. This is everything that's needed. So again, why do we need to have this here? It's because we cannot use import from derivation, and therefore all the Nix code needs to be here. So let's get that framework imported. We just use call package. The dream2nix directory, and that should be it. Okay, now we have dream2nix available. Now we want to build a package with dream2nix. As an example, I want to package a JavaScript program that's called Prettier. It's a formatter for JavaScript. So now I just execute the default app. Let's see what this gives me. So we only have one command right now. It's called package. This command is for creating a package. See what it does. Wants a source. Give it a source, and that can be like a flake-like reference, even if it's not a flake. And this will be prettier, and we want the main branch. And I have to select the output. I want to do this in a subdirectory called prettier. All right. So this is what it needs to get started. Now it's fetching the repository. You can see it created a directory here, but this is empty. So the fetching is just in memory. It doesn't fetch the repository, obviously, to the repository. Okay, so what can we see here? It wants us to select the translator. In general, the idea of dream2nix is to have many different translators for different frameworks and that support different metadata. Right now we have 3. We have one for Node.js that can parse our yarn log. We have another one for Node.js that can parse the package log JSON, and it uses some functions of npm log to nix. And then we have another one that uses pip for Python. So obviously this is not compatible, and it already detected, hey, this is a project. It has a yarn log, so the yarn log translator is the compatible one. So in this case, I just need to press enter. Now, since I selected the yarn log translator, the yarn log translator wants to know some more things, and it asks me whether to include the development dependencies or not. So if this would be another translator, for example, pip for Python, it would ask other questions or no questions at all. So I don't need development dependencies since I just want to have the program. I don't want optional dependencies. I don't want peer dependencies. Okay, so now it's translating the metadata. Done. So what has happened now? If we look into that prettier directory, there is now one file that's called dream.log. This is just JSON. I will explain a little bit more about this format later. But the important point to understand for now is that it's just data. It's not Nix code. It's just JSON. Okay, so now to include that package into our package set, we just say prettier is dream2nix rise and shine. And this wants one argument. Dreamlog is prettier dream.log. And that will return us different things like a shell and a package. We want the package. Okay, let's try building that. So we want to build all packages file, and we want to build the prettier file, the prettier attribute. It's probably cached, so let's do a rebuild. Oh, it's not cached. Okay, that's fine. All right, so now it's building the package. And you might recognize this log output. This is node2nix. So right now, dream2nix uses as a builder node2nix. This is supposed to change in the future. I already implemented another, or started implementing another builder, which doesn't install all the dependencies at once. But this is still, it only works for a few packages. So the node2nix one is still the more stable one, but I want to replace it in the future. So let's see, result, prettier. Right, it works. Okay. So now there's a second version, a second way of using dream2nix, which is basically much simpler, and which I'm going to demonstrate as well. So let's change the directory. I already prepared another directory, which is repository number 2. It's empty. Let's open this in VS Code. All right. So here we create a new file. Default.nix. And now we do it without installing the dream2nix framework, doing everything like kind of on the fly. So we say, let dream2nix be built-ins.getFlake. And we want to have the flake output lib, dream2nix for our platform. And then we just say dream2nix dot just build. And we say the source should be fetch tarball. GitHub prettier tarball main. All right. So now it does everything on the fly. See if that works. Mix build, default mix. Now you can see it takes a bit longer to evaluate. Why is that? It's because it does all the translation on the fly. We don't have that pre-generated dreamlog. It still generates it, but it does it on the fly, and it has to do that first. It has to detect which is the right translator. It has to generate the dreamlog in memory and evaluate it. But in the end, it's going to do, it's building the same thing right now. And of course, not every package might just build. So we have like options. We can pass some overrides here and all these kind of things. This is still kind of work in progress, but this will be possible. All right. So yeah, this was the 2 ways you can use dream2nix right now. Don't expect it to work with a lot of packages out of the box right now, because the builders and the translators are still at kind of early stage. But yeah, this is the general idea. All right. So how does that all work? Let me switch to my slides. Oh no, this is the wrong one. There we go. All right, so here I have the slides with the commands, so you can try it later. So one of the core ideas behind designing this was to not hard code a lot of procedures. Try not hard coding any procedures. We want to allow the users to choose all kinds of stuff. For example, do you want to generate code, or do you want to use pure nix to do everything on the fly? Or, I mean, there's arguments for both. Like most of the people say, oh, you should always use pure nix, but as we've seen, the evaluation time is significantly longer. So if you have a repository with 10,000 packages, maybe you want to decide to pre-generate all these log files and have it evaluate quicker later. So do we want granular fetching versus combined fetching? Like, do we want to fetch each source individually, or do we want to have like a fixed output derivations? But don't be scared. The reason we support large fixed output derivations is in case we have a package with 50,000 packages, with 50,000 dependencies, we have to store 50,000 hashes. And we can opt in fetching them all at once and only providing one hash. And it won't have the reproducibility issues like some of the large fixed output derivation fetches in nix packages, because what we do here is we just pass the list of URLs basically to this big fetcher, and it actually uses the exact same fetcher code. It uses the build scripts from the nix packages fetcher to fetch those. So it's actually exactly the same. It has the same reproducibility properties, just it allows you to only provide one hash if that's useful for someone. We want to provide different kinds of builders. Usually you want to have a granular builder. That's usually the best, but sometimes it's not possible or it's super difficult to do. For example, some build systems, they have regular cyclic dependencies. And in that case, it's difficult to do the granular approach because Nix can't deal with cyclic dependencies. Nix will run into an infinite recursion. So maybe you want to decide to build everything in one derivation, or maybe build parts of the tree in one derivation. This is what I'm working on right now with my new node builder. It basically builds as much as possible in a granular way, and the parts of the tree where there's a cyclic dependencies, it uses another builder that builds it in one derivation. So we have like a mix of both approaches. We want the user to be able to package sources from a local repository, like within the same repository, or from a remote repository, or just by specifying some requirements. We want to support all kinds of different log files. All the processes which come after the parsing should be independent of whatever upstream log file is used, so we don't have to switch the tool just because we have other log files. Excuse me. And the way of using dream2nix, there's different ways. I showed you the interactive CLI, but it can also be used through scripting, and it can also be used through IFD, and hopefully soon through RFC 92. Okay, another thing that is a little bit different here than nix packages is how we identify packages. Nix packages usually tries to only have one version of each package, but this doesn't always work. We need more than one version sometimes, and there is no enforced standard for that. So we have these very weird package keys. For example, for this foundation DB thing, for me, it's not clear which numbers, which digits belong to the package name and which belong to the version. Or for PyTest, is PyTest _6 the same as PyTest _6_1? It's not clear. Turns out it's not the same. And this is not only bad for the user, it's much, much, much worse for automation tools. So if you do any kind of automation on top of this, then it's super, super difficult because there's no enforced standard. So we decided we always want to identify packages by name and version. And don't be scared. It sounds a little bit more complicated, but actually, so far, you wouldn't need to choose the versions yourself. So the way dream2nix works right now, it has an understanding of the dependencies so that you don't need to pick dependencies manually. It does it automatically. But if for some reason you would have to, for example, implement that syntax, which is here under pick version, you could, for example, make a function pick that takes a package name and a semantic version specifier, and then picks the version that satisfies this. This has the benefit. If the package version 2.1 gets updated to 2.2, it doesn't automatically break other packages. This specifier still returns a valid package. But right now, as I said, this wasn't needed. This isn't implemented, but this is just an idea for the future, how to deal with these with different versions. All right, another important concept in dream2nix is that we strictly want to separate logic from data. So what do I mean by logic? Logic basically means it's built in fetch logic. So that's all the complicated stuff. That's where you need to write Nix code. We need to tell Nix how to build stuff and things like that. And data is that this would be, for example, URLs and hashes and names and versions and dependency relations, dependency trees. Like this is data. This is stuff which doesn't need to be in Nix. It can be in some stupid format like JSON. It's just there to express data. Yeah, so right now we have kind of this problem. Many of the current generators, they generate Nix code where the Nix code is a mix of logic and data. This is not so good. Some of them do it a little bit better. They generate several files per package. We have one file which is containing mainly the logic and another file which is containing mainly the data. This is already better. It's easier to see what's going on. It's easier to debug stuff, but it's still not optimal because we have the logic in many different places. So what we do with dream2nix is that whenever we generate something, and as you've seen, dream2nix doesn't always force you to do that, but if you want to generate something, we only generate data. We never generate Nix code. So that allows us to have the build logic only in one place. This has several benefits. It's much easier to analyze the relations between packages and to write some programs that work with this code in the repository and can analyze it and can modify it. It's much easier to do all kind of to build automation on top of this because JSON can be read by any kind of programming language easily and also modified. So this makes it easier. Also makes it easier to fix bugs or make improvements because we have the logic only in one place. But there is a big problem with this. So this is again the picture from the bottom right. We have these three packages. In this case, it's foo1, foo2, and bar1. So what if any of these packages needs some custom logic that's only needed for that packages because it needs something special. It needs something that wasn't caught by the automation, maybe an extra build dependency or maybe some patch. So this is where we have this concept of conditional overrides. So the idea of conditional overrides is to have one place in the repository where we have all the per package logic, where we fix up the packages. And it's similar to the overrides used in nixpkgs, but a little bit different. It has a condition. So to give an example, these are the overrides for foo in our case, and there are two overrides for foo, and each override has a condition and the actual override. In this case, the condition says satisfy semver everything above version 2. Every minor version above 2, and the other override has a condition that applies to everything that's 1 and above. So in our example, foo1 would get a patch, and foo2 would get a would get an additional dependency on Rust, maybe because it needs to compile something during build time. So what is the benefit of this is we allow to maintain several versions per package in a nice way. It reduces side effects between packages because we can make overrides in a way that they only apply to certain to certain package versions. It doesn't have to be the version, it can also be another condition, but usually it's probably going to be the version. So this reduces the side effects between packages, because with the old model, if we want to update the packages, we usually have to replace it. And if we have to replace it, we're going to break 5 other packages, we have to replace them as well. And this allows us to have like more decoupled workflows and to work a little bit more independent of each other without constantly breaking each other's stuff. Of course, we have to watch out that we don't flood the repository with too many different versions. But since we have this strict separation between data and logic, it's going to be much easier to run like intelligent graph optimization algorithms, for example, or re-resolving parts of the dependencies to reduce the total amount of dependencies. We can do all kinds of intelligent stuff now that was hard to do before, because currently, if you write any kind of automation on Nix packages, you will have to parse Nix code and generate new Nix code, which is hard. Okay, the general architecture. So the idea of dream2nix is that everything starts with some kind of input, or this can be really anything. In the demonstration that I showed you, it was the upstream source repository. This goes into a translator, and there will be many different translators for different build systems and different formats, whatever. And the idea is that a translator can also be implemented in many different ways. It really doesn't matter as long as it produces the same format, the same output format. So a translator, for example, can be implemented in pure Nix. This was the case with the yarn block translator that I just used. It can be implemented as a Nix build that just analyzes some data and produces a JSON file, or it can be totally independent of Nix, can just be an external program that's called and produces this JSON file. So all that matters is that all the translators will produce the same format, and that's our generic log format. That's this file that you've seen, dream.log. And what does this file contain roughly? It's URLs, it's hashes, and it's other metadata that is required for the build to work. But it's the minimal metadata that we need for the build to work. We're not copying a lot of information. We just store the minimal information in a specified, structured way that will later be read by the builder and converted to a derivation. So yeah, so the last two layers is the fetcher. The fetcher just reads the URLs and hashes part of the generic log and ignores the rest. The cool thing with this model is that the fetcher basically is always the same. The fetcher really doesn't care about the build system. It doesn't need to understand if we're building Python or Node.js or Rust here. Fetching always works the same, and we can use exactly the same logic for everything. This allows us, for example, to make some nice user interfaces for certain problems that happens. For example, maybe a hash is missing or a hash is outdated or whatever. We can solve ways in a standardized way. We can solve problems in a standardized way. And then the last step is the builder. The builder gets the fetched sources from the fetching layer, and it reads the metadata from the generic log and then generates one or more Nix derivations. Yeah, so here is a quick example of how this generic log looks like. So we have 3 different sections. There's the generic section, which is the same for every build system. There's a sources section, which also looks the same. This is like a standardized format. And then we have the build system specific section, and this is standardized by the subsystem, by the specific build system in dream2nix. So just to look quickly over it, in the generic section, it will tell dream2nix, oh, this is the Python build system that this package has to be built with. The translator which was used to produce this was the Python impure pip. And also we want to store the translator arguments. Why do we want to do this? This allows us later to just rerun the translator. For example, if we want to make an update, we just need to rerun the translator with exactly the same arguments on updated versions, and we can do the package update without really having to do anything by hand. What is the main package? Then we have a key that is remove dependencies. I introduced this because sometimes we have cyclic dependencies, and dream2nix removes them from the dependency graph by default. And this is actually a bit outdated. Usually it's going to be a list of the removed dependency dependency edges. And then we have the dependency graph. So in this case, we have just two packages. Request depends on certify, but this is a list. It could depend on multiple other packages. The source describes in a generic way how to fetch these things. It has the URL, the hash, and tells the system how to fetch it. And the build system, this thing, in order to know what kind of format this will be, we have to look at the build system attribute here. It's Python. So the Python subsystem will specify this, the structure of this. And Python wants to have a Python attribute. This is the Python interpreter version. And the source formats, because there's two different formats a package can be, and so it can either be as dist or a real package. Yeah, so translator types. We have three different translator types, as I already quickly explained. Translators implemented in pure nix, translators implemented in recursive nix, or IFD, or whatever that uses a nix build to do the translation. Or we can have impure translators. And I want to give a quick overview, like why we need exactly these three categories and when we can use one or the other. So there are three different criteria which restricts us in using these kinds of fetches. The first one is the question, does the upstream metadata that we are processing, does it contain URLs and hashes? If it doesn't contain URLs and hashes, obviously pure nix can't process it, because we would have to do network access to get the URLs and hashes, and it can't do that. The second question is, does nix itself understand the hashing algorithm? If we have all URLs and all hashes, but if nix doesn't understand the hashing algorithm, we also can't use pure nix to do the job. And the last question is, can the nix language process this format? And of course, obviously, nix is Turing complete, so in theory, it can process everything, but in practice, some stuff is just too complex to process. So we might prefer not doing it in nix just because it's too inefficient. Excuse me. So the recursive nix style is the one that we can use if it's too complicated with the nix language to process it. It still has the requirement that we need all the URLs and hashes, and it still has the requirement that nix needs to understand the hashing algorithm. Otherwise, again, we would have to do network access in the nix build, which we can't do. But we can use any programming language to do the transformation. It can be Rust, it can be Haskell, it can be Python, whatever. It really doesn't matter. And it's still pure. It's still as pure as the pure nix, but it requires a nix build to do. And if any of those first two conditions isn't met, then we can't use these approaches. We need to have an impure translator, which is like a separate program, which is called, and it's usually the simplest way of doing it anyways. So this is probably one reason why many Unix tools, they just use like kind of impure network access to create their Nix code or whatever. Like this is kind of the idea behind this as well. Okay, so how do I think can this improve Nix packages? First of all, so the idea is, let's say dream2nix gets more mature and we can somehow use it for some frameworks, Nix packages. What do I think will be the main improvements by doing this? First of all, we have the strict separation between code and data. This in general supports automation. It will be easier to write tools for updating, analyzing data, all kinds of things. It will be easier to deploy optimizations since there's not a whole lot of different code. There's not a lot of different code that we need to change. We will have automatic or at least much simplified package updates. I would say that in most cases, dream2nix will be able to just fully update fully automatically provide like an update script. It's not really a script, it's just update procedure. It's generated on the fly, but of course it doesn't always work. Sometimes packages change, or maybe they need like a super custom process. But the idea is that to have to write an update script should be the exception and not the norm. Another thing is we're gonna remove a lot of duplicated code by not having a lot of generated code in general. We reduce caching overhead because we try to have all our builders built created in a way that they don't do these huge derivations with many dependencies. We try to have like an optimized approach for building stuff where as much as possible is shared between at least on a caching perspective between packages. Another goal is to remove complex fixed output derivations completely. Like the way fetching works in dream2nix is it doesn't have these problems. We do not execute complex code inside fixed output derivations, so we don't have the reproducibility issues. One goal is to have consistent interfaces across different languages and across different frameworks to make it easier for people. Like once they learn how to update stuff with Python, they can easily also do it with JavaScript. So yeah, unified workflows, kind of the same thing. And in general, also one major goal is to speed up the innovation, since we have a common basis where we can try different approaches, try new Nix features. For example, the way dream2nix is built right now, if we integrate computer derivations RFC92 into it, then once that gets enabled in Nix packages, it will automatically be enabled for all kinds of packages, which earlier maybe they just support IFD or code generation, but now they're going to support RFC92 as well. And we don't have to update 20 different tools in order to have that new Nix feature used. All right, so what is the current state of dream2nix? As you have seen, we have a working command line interface, which you can execute like this. We have a working import from derivation interface, and we have some translators and builders for Node.js. So I have to mention they are pretty alpha by this at this point. So don't expect it to work with your package right now. There's still a lot of little things to improve and little features to add and corner cases to solve. Okay, what are the next steps which are important in my what are my ideas? What could be the next steps is I want to focus on delivering a great tool for Node.js first. I think it makes sense to like focus on one build system and optimize it for that. Also think that this could be a great thing for Nix packages, because right now a lot of things in conjunction with Node.js are kind of confusing. And to do this, I think we might not get around creating our own package repository, like Dream packages, for example, to test, to package a bunch of packages and test our features and demonstrate some features. And when we did this, we hopefully get an idea about our APIs, how exactly they should look like. And once we have some stable APIs, we can hopefully start using it in Nix packages for Node.js. And then, of course, continue to integrate many more build systems. And actually, this is already in process. Right now, there are already some people who are working on translators for other build systems than Node.js. So yeah, thanks for listening to me. Please join the Matrix channel if you like. We can have some discussions there. Feel free to contribute on GitHub. And I think now is a good time to have some questions maybe or some discussions. If you don't have any questions, then there's some other topics that I am interested in talking about. So we can just talk about those. But I think it's it's not the biggest priority. Let's have some questions and some discussions maybe.
Okay, can you hear me? Yeah. So there is already a first question in the shared notes, and then now there's a second. Did you see those?
Oh, shared notes. Here we go. It's loading. Aren't conditional overrides causing memory issues? As far as I'm aware, derivation overrides is basically caused by evaluation of nix packages takes up so much memory. This is a good question. As far as I understand, the problem we have with overrides in nix packages, or at least one of the problems, is that it prevents garbage collection, but I'm not sure. Please correct me if I'm wrong. But yeah, it probably might not have much better properties than it has in nix packages. It's probably a little bit worse because in nix packages, if I have an override, it's clearly assigned to a key, and here I need to check the condition as well. But we have it assigned to a key and a condition, so it's not like we have to evaluate all overrides against all packages. The overrides for foo are only, the conditions are only going to be checked if the foo package is built. Yeah, by the way, feel free to turn on your microphones, whoever wants to. Maybe it's a little bit easier to have a conversation like this.
Okay, second question.
So
how does your work? I can read it, then we have a conversation.
Okay, that's good like this.
How does your work on mach_nix influence your work on dream2nix and inversely?
I mean, by doing mach_nix, I had a lot of I made a lot of experiences that probably now help by creating dream2nix. So in that way, it influences each other well. But to be honest, right now I pretty much stopped maintaining mach_nix, and I'm just focusing on dream2nix because the idea is to replace mach_nix at some point with it. So I'm not gonna be focusing on mach_nix anymore. I think in the next, in the upcoming times. Yeah.
Okay. Any other 2nix? Did you actually work on any other 2nix tools?
Not in the sense that I created them, but I had to deal with a bunch of Node.js packages during the summer of Nix, so I was forced to look a little bit deeper into some of the existing Node.js to Nix tools, and I have worked on them in a way that I've taken some parts of them and now integrated it into dream2nix. So in that way, yes, but I haven't really maintained any other tools.
Okay, I know that's great. Also hearing that forcing you to look into Node might have a positive effect.
The crazy thing is, actually, when I started doing dream2nix, I only wanted to create a better tool for Node.js. And then I sat down, I thought, okay, how can I make it better? So what is the problem of the current tools is that all these kind of problems I was talking in the beginning. And then I thought, okay, if I really want to make something that's really improving things, it should probably be like a framework that works for everything. And this is kind of the way. But originally, I just wanted to do something from Node.js for Node.js, which is probably also now the reason I first want to focus on Node.js and do that properly and then look into other things. But in general, the architecture should work for everything. That's the idea.
Okay, then we have another question. I'm still a bit unsure how this would integrate into Nix packages eventually. Would every package need one dream.lock in tree?
As it's designed right now, yes. So the idea is that every package will be defined by a dream.lock. Obviously, the disadvantage by this is that we have a lot of data in Nix packages, and there will be redundant data also because right now, as it's built, if two packages have the same depend on something, then this URL, this hash of this dependency will be twice in the tree. And actually, that's a topic we've discussed already several times in like the chat and codes during the summer of Nix. So how can we like improve that behavior for shared dependencies? I haven't yet worked anything out specific in a way that I implemented something, but my current idea is to have something maybe like a two-stage process where if a maintainer creates or updates a package, they work in isolation. They just update their package and manage their packages completely independently. And once every staging cycle, we can go through all these log files and see what are the similarities, and then create like a central dream.log, which has all the packages which are like shared among the dependencies. And we can do this every now and then like packages, instead of only having their private dependencies, they would start referencing some of the dependencies to that global place. So why should this be a two-stage process is because we want to prevent these merge conflicts that we have right now, for example, with Node.js, where whenever somebody updates something, and somebody else updates something as well, it will make conflicts. But with this two-stage process, it's only done once every few weeks by a single person, and it's not multiple persons who write regularly to this central thing. That's kind of my current idea. But if you have any ideas of how to solve that problem, let me know. I think that would be, to get some more ideas on that, that would be very valuable. Another idea, which I quickly want to throw out, which was mentioned yesterday in a discussion with Raphael, is that instead of having our own log files, what we could also do is we reproduce the structure that's there in Nix packages right now for many packages. So basically, by design, every package only references their direct dependencies, and those dependencies are managed in another dream.log, which also again only reference their direct dependencies. I think we still have to play a little bit with these ideas and see what might work best. If you have any ideas, please join the Matrix channel or just turn on your microphone and spit them out. I'm very interested. Is
Cool.
Rise of China a Half-Life reference? I actually don't know. I haven't really played Half-Life. Oh my god! I said it. I don't know. Probably not. I just thought it's related to dreaming. So, okay.
Okay, and then we have one last question. What would you tell the upstream package management developers? Well, that's strange. I wrote this, so sorry. So for example, to the node maintainers and to the cargo packaging team and so on, can they do anything to support such a tool?
This is a good question. I think, how do I answer this best? So the way things work right now, where we just parse log files and use log files, obviously the best thing that can happen to us if those log files are precise and follow a precise standard and always contain hashes and all these kind of things. But I also think that the end goal of Nix should not be to read log files of other package management. So I actually prepared some slides for this. Let me quickly go through this. Okay, so as you may have noticed, Nix is not really a first-class package manager for individual programming language. So usually it's always done that way, that if you develop something in a programming language, you will use the upstream package manager in the dev environment to quickly switch between dependencies or something like this, or to generate the the dependency tree, the log file, whatever. And then nix is like the second brother, which somehow tries to fight with the data and make something out of it. And the main problem of this is, or okay, there's probably several problems that prevent nix from replacing these tools, but one of the problem is that nix can't resolve dependencies. Nix does not support dependency resolution. So to quickly explain what that is, here an example for Python. If you declare dependencies with pip in Python, you can have a requirements text. It's just the package names. And what the pip then does, it runs a resolver and decides, oh, for pandas, I'm going to use the version 1.3.3, and NumPy, I'm going to use this version. When you add something, for example, TensorFlow, now you see the version of NumPy has been downgraded. So the resolver, why is that? Because TensorFlow has a restriction on NumPy. TensorFlow defines NumPy must be bigger than this, but smaller than this. So all these packages in the background consists of a set of requirement specifiers, requirement constraints. That's the right term. And the resolver basically tells you what kind of packages you need in the end to satisfy these constraints, and Nix can't do that. And it's a thing that is basically required for all kind of for upstream package managers. And as long as Nix can't reproduce this, there's a problem. So what might be one reason why this is difficult to do for Nix is because usually how it's done, it's not reproducible, because this resolution process, it asks some API, some online index. And let's say tomorrow they release a new NumPy version 1.19.6, and I rerun this resolver, it will tell me to get 1.19.6. So it's not reproducible. And this is basically the time where they invented log files. They say, oh, damn, we want more reproducible builds, but this can't be reproducible at all. So what they did is they create log files, which is just like a snapshot of what you have done, what you have resolved. But I think it's important to understand that log files have been invented to solve a reproducibility issue. They are not a solution for dependency management, and they're meant to be read-only. They're extremely verbose, and they produce management overhead. And if we're putting ourselves in a position where we say, okay, the standard way of doing things is to read upstream log files, we will basically make ourselves dependent on code generators. Oops. So we always need another code generator to produce this log file for us. We are not the ones who are managing it. So as long as Nix depends on reading log files, Nix is not the entry point for package management, and Nix will be kind of held hostage by other package managers, and it's not going to be able to replace those tools. If we want to be able to replace those tools and to be like the first thing, the entry point for package management, we need to be able to do dependency resolution. Let's quickly talk about how this could, right now in Nix packages, there's an interface looks a little bit similar. So for some frameworks, we don't even try to do that. We don't really support loading like arbitrary libraries into dev environments. But for Python, we do, and our interface looks pretty simple. It looks pretty similar actually to what we've seen in the requirement text, but in practice, it's quite different. The problem is it only works for a limited amount of packages, and it only works for exactly one version for each packages. If you upgrade any package, you risk massive breakages, and yeah, it's in general very, very fragile. So what would be required in order to do it properly, to have like the same user experience or the same feature set like pip does, first of all, we need to have this separation between data and logic that allows us to manage and it's conditional overrides that allow us to maintain several different versions, but also Nix needs to be able to resolve these constraints. And we can now build something with IFD or with recursive Nix that does it, but it's probably going to be inefficient. So maybe at some point, like if we experiment with that, and if we can show that this is a useful thing, maybe we can have like a built-in resolve constraints, which takes a list of these constraints and tells us, okay, this amount of this set of packages satisfies these constraints, and then we're going to be able to not use any log files anymore. We're going to have a reproducible resolution process, and we basically don't need that log files anymore. Yeah, and we're not going to be the hostage of other package managers. Okay. Okay, I guess let's continue with the next question. Do you need more coordination from 2nix tool authors, maintainers? Do you hope to gather previous 2nix to your own dream? Yeah, of course I do. I think it would be amazing if some of the already existing package maintainers for the other tools, if they would decide to help me integrating their work into dream2nix, and I don't have to do that by my own. That would be really cool. All right. Do we have any more questions?
I think not right now. I mean, you can continue discussing. I really have to go to another meeting already quite late. But thanks a lot, David. That was a great talk.
Thanks for being here and listening, and thanks for moderating, Matthias.
Yeah, I didn't moderate much, but with pleasure. Thanks. Bye. Ciao.
Bye-bye.
So we have recorded here. I'm going to post this now.